So the two real things I need here is you need to define lateral faces. And this is on page 564. I need you to find lateral edges. Okay, I need you to find lateral area and surface area. Surface area you've done before, lateral area you might not have. So go ahead and define all those things. Then we're going to do our formulas. And we're going to do two formulas in this concept. We're going to deal with this shape, and we're going to deal with this shape. Let's straighten that up. Out of focus. So these two guys are the ones we're dealing with today. And I'll show you how to work problems. Okay, hopefully you found lateral faces. So a prism is a polyhedron with two congruent faces called bases. We went over that yesterday. That lie in parallel planes. We didn't go over that. The other faces are called lateral faces. Okay, so basically these are the bases. And these are the lateral faces. Okay? So there's two different things. In this room, the floor and the ceiling would be the bases, and the lateral faces would be all the walls. So typically, if we were going to paint this room, we would only paint the lateral faces. You don't usually paint the floor and the ceiling in this kind of building. At your house, you probably paint the ceiling. I've seen some people paint the floor in their house. It's not uncommon nowadays. Usually they don't do it with paint, they do it with like concrete stain, right? Have you seen that before, stained concrete? Mm-hmm. That's kind of painting, right? Sort of? Yeah. At least changes the color with a brush.
Some people paint tile.
Some people paint tile. Especially if you have really old, ugly 70s tile. The problem with painting tile is it will chip. But sometimes you got to deal with... Yes, that's why they have a lot of good stuff that you can do. So if you spend the money, you can get it done correctly. All right, so lateral edges. What does lateral edges say? It says the segments connecting these vertices are lateral edges. Well, which ones are the vertices? The other faces called lateral faces are parallelograms that are formed by connecting the corresponding vertices of the bases. Okay. Those are what are called the lateral areas. Okay. And then here we are at surface area and lateral area. Lateral area is the area of all of the lateral faces. The surface area is all of the lateral faces plus the bases. Okay, so now we're going to get to the formulas, because that's really what this is about. So these formulas are very generic. They're not specific like they were maybe last year. And again, you probably didn't get to them last year. Back way back in the long time ago, when I taught 8th graders, we had to go over all these specific formulas for every single type of prism. We don't do that anymore. Nowadays, we just teach one formula for all prisms that we can deal with. Now, there are certain rules that we will follow. Basically, what we're going to follow here is, yes, the prisms don't have to be like this. They actually can have parallelograms where they're slanted, which I can't make this slanted. But more or less, they're going to have both sides to be a prism are going to be congruent, both bases anyways. And then all of the faces are going to end up being congruent too. So that's, this only works for prisms basically. Okay, so lateral area, that's what L stands for. So L is lateral area. And we use a capital L. And just basically a capital L just means it's for your three-dimensional shapes. Well, it doesn't mean that. It just means it takes work to get it, more or less. P stands for perimeter. I did it again. Perimeter of the base. I want to make it all E's, but it's P-E-R-I. Perimeter of the base. H is the height of the shape, or you could just say it's the distance between the two bases. Okay? So essentially, if we have like our little so if we essentially have the thing, we're looking for the perimeter of the base. So we're going to look for the perimeter of the base right here. That's going to be your P. And right here is going to be your height. And it can be really any of these edges, right? That's going to be your height. All right, so this is how you're going to do your problem. Okay, I'm going to assign this. I'm going to put some numbers here and just kind of assign it. I'm going to call this 8. I'm going to call this line right here 6. And I'm going to call this line right here 12. This is how I want you to do your problem. I first want you to draw the base. So draw the base. Because that's the most important thing for all the problems. Understanding what the base is. My base here is a rectangle 8 by 6. Draw the base, and I'm going to write right here the other number I need. Height is 12. Okay, so to use the formula, lateral area equals perimeter. What's the perimeter of this? Well, we know that it's going to be a shape like this, so it's going to be there. It's just a rectangle. So that would be what? 16, 12, 28? Because that's 16 and that's 12, so that should be 28? Is that right? So this is the base, the perimeter of the base, and then I need to multiply it by the height. That doesn't seem too complicated. But get used to drawing the base so you don't get confused which numbers go where. Because again, I had to add up, to get this number, I had to add up 4 numbers. So what is the lateral area? So it's what, 28 times 12? So it's what, 336? Units squared. So lateral area is still an area, so you would still have units squared. Probably on your worksheet, because it is a worksheet today, it will have, it will have units, so you have to put those units. So that's lateral area. Let's look at surface area. And if this is not on camera, I'll move it. Surface area. The formula for surface area is pretty easy. And it's going to be S for surface area equals 2B plus L. Okay, the capital B stands for the area of the base. Okay, it's 2 of them because we have 2 bases, right? So 2 times the area of the base plus L. That's still the lateral area. Okay, so you have to calculate the lateral area to get the surface area. In your book, they have other things that you can do. They have another formula, it looks like. Lateral area, they just have one formula. The second one, they have AP plus PH. What does the A stand for in your book? What do we think? AP plus PH. So this would be perimeter, and that would be what? The apothem? Okay. So you can use that too. I don't usually do it, even though we might have an apothem problem, and I'll show you one in a little bit. I usually just focus on this formula. You know how to find the area of all kinds of bases, right? And just find the area of the base, times it by 2, add the lateral area. Yeah, I just did that. That's in your book. I don't usually complicate it with extra formulas. Just like I'm not going to complicate this shape. This shape's not, well, you know, we don't have a perimeter, first of all, for this shape, do we? Instead of perimeter, we call it a circumference. So we're going to work on this shape next. In the book, they have these formulas, but I don't use them. I don't like the formulas because I don't want to learn any new formulas. I would rather use, for lateral area, I would rather use perimeter times height for a cylinder. Now, technically, you can't have a perimeter, so I guess I could do LCH. Should that be the same thing? So basically, this is what you need to do. And if you look at your book formula, which you may use, and I'll record it. I don't use it usually because of this. We'll call this 5, and we'll call this 13. Because all I need to do is the same thing. To find the lateral area, I need to draw my base. And I need to find the perimeter of this base. In this case, the circumference, which is 2 pi r. So that would be 10 pi. So, and then I need to multiply it by the height. So L is going to equal 10 pi r times 13. So that's going to be 130 pi. And they're probably going to have me round it, so I just put in the calculator. And that is going to end up equaling 408.41 units squared. Okay? Now, in the book, they have a formula for you that you can use. They have a formula that looks like this. For lateral area, 2 pi RH. Okay, that's fine. That's basically what I did, isn't it? But instead of having a different formula so I can get confused, I just used the same formula and came up with it on my own. Okay, just like surface area has 2 different formulas for cylinder. So surface area can be 2b plus L, just like we did before. Or it can be, instead of 2b, 2 pi r squared. That's the area of a circle, right? Plus 2 pi r h, which is the circumference. So I just focus on this and just worry about getting the area of the base, regardless of what it is, and the lateral area. So that's basically what we're going to do. Last thing we're going to do is I want you to know what would happen if I were to fold this into a 3-dimensional shape. What shape would it be? It would be a cube or a rectangular prism, right? So this is called a net. A net is basically when you fold and unfold a 3-dimensional shape where you look at all the faces on a 2D surface. So if you were going to design a paper toy or a paper building, you would have to have all these sides to build something like this, right? So believe it or not, that's part of our requirement. So we have nets. You got to name your nets. That's it.